One of the most striking differences between humans, and also a source of huge conflict and prejudice, is skin colour. But why did some humans end up white and some black? That's been a long-standing research focus of Dr. Nina Jablonski, who's a highly respected paleoanthropologist at Pennsylvania State University. She thinks it's at least partly about vitamins, and one in particular.
The whole story of skin color we can think about as really the story of vitamin protection and production. And in connection with vitamin D, we've known for a long time that it's important in making it possible for our gut to absorb calcium. And so you need vitamin D to build a strong skeleton, but you also need it to maintain a strong immune system. And so now as we look at the many functions of vitamin D, we think not only about building strong bones, but about maintaining a strong immune system. And that may turn out to be the most important suite of functions of the vitamin, that it really helps to maintain our immune system in tip-top shape so that we can resist the assault of bacteria and viruses on our skin, as well as things that we ingest and breathe.
Why do you think vitamin D has such a strong evolutionary force to produce something so potent as skin color?
We know that skin pigmentation has biological meaning because we can see that it's distributed in a particular pattern over the Earth's surface. We see more darkly pigmented people concentrated closer to the equator, and more lightly pigmented people grading toward the poles. And so people have known for a long time that this has biological significance, but they didn't know why. And so our work has been trying to identify the forces of natural selection in evolution that may have led to this conspicuous and important pattern.
How have you studied it?
We've tried to see what physical factors, especially what parts of sunlight, are more strongly correlated to skin pigmentation. We found that ultraviolet radiation is the most salient part of sunlight that affects skin pigmentation, and that dark pigmentation is a very effective sunscreen against the harmful ultraviolet rays. We see lighter pigmentation as we go farther away from the equator, where ultraviolet light is less intense. And among lightly pigmented people, it's actually important that there be less sunscreen pigment so that some ultraviolet radiation can penetrate into the skin to make vitamin D. And so what we see in zoological terms are really two gradients. One that protects people against the harmful ultraviolet rays, really high levels at the equator, and another gradient that allows maximum amounts of ultraviolet radiation in for people living closer to the poles.
Does it happen with non-human primates and animals? Do their skin colors change or their fur colors change?
We see some of the same effects, but not quite as much, because with furry animals, they're actually able to get a lot of their vitamin D by licking one another. So they make vitamin D in their skin, in their fur, and then they get it when they groom one another, or infants or mothers get it from their infants and so forth by licking. And so there is the interface between the sun and the skin, but it's more indirect. And also many animals have more dietary ways to get vitamin D, whereas humans tend to have fewer.
Humans spread reasonably quickly.
Yes.
Out of Africa. How do you marry the speed of spread of humans with the slowness of evolution to create different skin colors?
Well, what's so interesting is when people dispersed into areas with much lower levels of ultraviolet radiation, those individuals who had particular genetic mutations or variants that imparted lighter pigmentation to their skin had a prodigious advantage over others.
Because vitamin D was so low?
Because vitamin D was so important, and the ability to make vitamin D from ambient levels of ultraviolet radiation was so important. And so we see these genetic changes being sort of catapulted into 100% frequency over the matter of just a few, tens or hundreds of generations rather than hundreds of thousands. So evolution can move quickly.
Because their babies would have suffered, and these families with darker skin would have had lower reproductive capacity.
That's right, that's right. And so all the time when we're talking about evolution and natural selection, we have to think about what variants would have allowed people to reproduce successfully and have their offspring in turn reproduce successfully. And having depigmented skin under low ultraviolet radiation conditions turned out to be monumentally important because it allowed them to have high levels of vitamin D.
So how do you explain the success of African Americans in North America following slavery, when very quickly they were moved, albeit to very similar tropical environments, but then spread throughout the United States to quite low ultraviolet light environments?
So although many of the African slaves who were working out of doors probably were able to stay quite healthy because they got quite a bit of sun exposure, those who lived indoors had a completely different trajectory. And in fact, we know that many African women and their offspring who lived indoors had tremendous problems with rickets and childbirth as a result. One of these interesting things as we delve into the human genome, we're discovering that in Africans we have a series of other genetic variants that are protecting the skeleton under these sort of low vitamin D conditions. And what we're now trying to understand is how Africans can maintain a strong skeleton and high bone mineral density under relatively low vitamin D conditions.